3.5, equation solving and modeling. So basically this is using like the L and the E to solve the equations. They say to like solve and check. I'm not really worried about the check part. I mean, you can if you want to, but it's just throwing the number back in. So number 2, 32 times 1/4 raised to the x over 3 is equal to 2. So we'll divide by 32 first. So we get 1/4 raised to the x over 3 is equal to 1 over 16. So at this point, there's nothing more I can do other than it's an exponential, so I can use a log to solve it. So I use the L. So log base 1/4 of 1/16 is equal to x over 3. We can take and multiply by the 3, so when we put it in the calculator, we can do 3 and then the log base, so 1/4 of 1/16 is equal to
6.
Yeah. No, I was thinking about what that reduced fraction was. Like, I was thinking about how that would be like 6 over 3, so I was like, it'll be 2. So when you said 6, I was like, should be 2. It's like, oh, that's the reduced. Delayed reaction. But anyways, yeah, you would just plug it back in and make sure that the left side's equal to the right side if you were to check it. But I'm not worried about that part. 6. 3 times 5 to the negative x over 4 equals 15. So divide by 3, so we get 5 to the negative x over 4 equals, nope, not 5. Nope, not 3. Not it is 5. Okay, words. Now, with this one, you can technically do it still by doing the L, or we can remember the properties that we've had that said that if this base is the same, then these powers have to be the same. So then that would mean that negative x over 4 would have to be equal to 1, because this is technically 5 to the 1. So then x is equal to negative 4 would be the answer for that one. All right, 10 log base 4 of 1 minus x is equal to 1. So I have a log, I need an exponential to solve it. So I do the little E curly Q thing. So 4 raised to the 1 is equal to 1 minus x. So 4 minus 1 is 3 is equal to negative x. So negative 3 is equal to x. So the next ones are basically doing the same thing, except for you're like definitely going to need a calculator for them because they're decimals, which they don't specify for you to use a calculator, but there's no way you could do it without one. So 12.98 raised to the x equals 1.6. So we have an exponential, use the L to undo it. So log base 0.98 of 1.6 is equal to x. And let's go 2 decimal places for the answers.
Negative 23.26.
Let's see, 14, 80, and then e to the 0.045x is equal to 240. So divide by 80, so e is equal to 0.045x, or sorry, e raised to the 0.045x is equal to 3. And then, now log base e we write as what? ln, so this is going to be the ln of 3 is equal to 0.045x. And then divide by that. So when you type it in, you can do ln of 3 divided by 0.045 is equal to x. Let's see. 18, 3 minus the log of x plus 2 equals 5. So I need to subtract the 3 and divide by a negative, so that's going to be negative log of x plus 2 is equal to 2. So log of x plus 2 equals negative 2. And you could do that all in one step if you wanted. So I have a log, need an exponential to solve it. So that's common log, so it's log base what?
10.
So we're going to have 10 to the negative 2 equals x plus 2. So 10 to the negative 2 minus 2 equals x. You can probably do this one without your calculator.
Wait,
It's
whatever,
like
90.
1 over 100
Oh, wait,
two.
no. I did not see it.
1 over 100 is 0.01, right? Minus 2 would be
Negative 1.9.
1.9
Yep.
That's it, Virginia.
All right, solve each equation by the method of your choice. Support your solution by a second method. I also don't care about that part. If you can solve it, you don't really need to do it twice. So 26, ln of x squared is equal to 4. Any suggestions on how I should think about this one? Or what I should do? Have a log. How might I go about solving it?
Can you do the L thing? Or no?
Well, I have a log, so I need
Do we want to do the E thingy?
the e.
Oh.
So, because ln is log base what?
E.
E. So I'm going to have e to the 4th is equal to x squared. Now what? Trying to get x by itself. Take the square root of both sides. What happens when I take a square root? Positive and negative. So x is going to be equal to e squared, or x is going to be equal to negative e squared. And that comes out to be 7.39 or negative 7.39 if you wanted the actual. The book shows both answers, so. Right, there's one problem that I might end up showing you later, but I'm not going to show it to you right now, because if I showed it to you right now, you're going to be super confused. Not that you won't be later, but if you have a little bit more of a foundation of this stuff first, you might be less confused. So we're going to wait on that one. So I'm going to skip number 30 if you're like worried about them being in order, but it's going to take like probably a half to a whole page of paper to do the problem. So that's why I'm skipping it for right now. And we're going to go to 38. Slightly easier problem. We've got log of x minus 2 plus the log of x plus 5 equals 2 log of 3. Any idea what I might need to do with this one? Or anything you see that I could? I could condense the logs. How would I do that? Or what's that going to look like?
Log of x minus 2 times x plus 5.
Yep. Now, what might I do on this side? What can I do with this number that's out front? So I'm going to do this as log of 3 squared, or you can write it as 9. It doesn't matter. Now, what do I know must be true?
The other one has to be log 3 squared. End up being that.
So x minus 2 times x plus 5 has to be equal to 3 squared. Because this is the same log, so that means what's inside has to be equal. So I'm going to go ahead and FOIL this just to save a step. So x squared minus 2x plus 5x, so plus 3x minus 10 equals 9. So then x squared plus 3x minus 19 equals 0. Can I factor that? What might I need to do? Quadratic formula.
Okay, our favorite.
Negative 3 plus or minus the square root of 3 squared minus 4 times 1 times negative 19 all over 2 times 1. Now, I'm going to save you from having to type all that in. This is going to be equal to 3.11. Now, I only have one answer, okay? That's works, and I honestly don't remember if it's the positive or the negative one off the top of my head. But anyways, but only one of them is going to work because you cannot have a negative inside of a log. So if I plug this number back in, everything's positive inside. But if I did the other one, like whatever the other answer is that comes out of here, it would end up giving me a negative inside of one of these. I'm pretty sure it's this one. But anyways, it'll end up giving you a negative. It might be a negative in both. And so that would cause a problem. And so that's why there's only one, even though based on this, we should see 2 answers. So if you are so inclined to want to type that in later, you're welcome to do that. But I'm not going to. All right, like I said, we'll skip 30 for now. It's not as bad as I'm probably making it out to be, but people always get confused, so I'm mainly going to show it to you in case it happens to come up on your AP exam. I hope they're not that cruel, but just in case. I'm going to do 2 order of magnitude problems. Probably like, what in the world is that? Basically, it's just solving down how many orders of magnitude, like, the quantities differ by. So, 42 says lemon juice with a pH equal to 2.3 and root beer, if you know what I mean, with a pH equal to 4.1. You can see what the book actually says later.
Like, root beer.
I'm just gonna put that in quotations.
Beer of the root.
Once we're done, I'll tell you a funny story.
Okay.
All right, so basically, I'm just taking the difference in these numbers and figuring out, like, order of magnitude. Now, order of magnitude is, like, powers of 10. If there is not a power of 10, we just write the number that it is. So, like, with this one, it's just going to be 4.1 minus 2.3, which should be 1.8. And so that one, there's no, like, order of magnitude. There's no, like, power of 10, like, quote-unquote difference. But this next one says the sound intensities of city traffic at 70 decibels, which is what dB is, and rustling leaves at 10 decibels. So we still do this the same way. We still do 70 minus 10, which is going to be 60. But because it's like a power of 10, it's kind of like order of magnitude you can think of as like, what is that word? Scientific notation. And so if you could make it a smaller number, like moving it over so it's just like, you know, like a single number in a decimal or something like that, that's what we would do. So in this case, this would actually be equal to 6 in terms of order of magnitude difference. It's 6 times as like intense of a sound, basically, is what that means. All right, problems for this section. 1 through 17, every other odd. Make sure there's no problems there I need to take out. Okay. And then 25, 27, 37, and 41.